Good day, friends. Right now, let's try to solve this problem. A dumbbell consists of two small balls, each of mass m, joined by weightless rigid rod. It is placed inside a smooth spherical cavity as shown. One ball touches the lowest point of the cavity and the other touches the side. The rod is at 45 degrees to the vertical. There is no friction. Immediately after the dumbbell is released, find the forces with which the two balls press on the wall of the cavity. The balls are much smaller than the radius of the cavity. Okay, so we're given with such a picture, yeah, and well, what we have here, we need to find what it is said there is no friction, but we need to find what we need to find the forces which are acting, find the forces with which the two balls press on the wall of the cavity. So basically, we definitely know it is normal forces, right? So we can see this picture and it makes some analysis. We definitely know. We can start from the very beginning. Yeah, it's really easy. We know this is mg. We have here definitely mg. Also, what we have normal force acting here, normal force acting here, and there is no friction. And also, what this rod is important, even though it is weightless, it has no mass, it still can have an applied force. So this rod pushes this object like this and pushes this object like this. Yeah, it's the same thing like, in fact, not rigid rod itself pushes the balls, but instead they act on each other through this rigid rod. So that's how we can write it something like this. This is F applied and this is F applied here, okay? Also, we know that, well, if this is 45 degrees, this is 45 degrees as well. This is also alpha. And the same thing we can apply here. This is alpha as well, okay? We can break down this force into two components, which is this one and this one. We know that, or we can write it like this. It doesn't change the idea. Upward and to the right. Upward is F sine alpha because it's opposite to the angle. And this is F cosine alpha because it is adjacent, okay? The same thing happens in here. So basically, we have here to the left and downward as well. Downward it is F cosine alpha because it is what it is adjacent, and this is F sine alpha because it is opposite. Okay, good. But the problem is about this problem is not the hard part is not about analyzing some forces. It's easy. It's easy. The problem is about another thing. So this word is really important. Immediately after the dumbbell is released, find the forces with which the two balls press on the walls of the cavity. The problem is, immediately after we release this dumbbell, it does not go circular. Why? Because at the instant we release it, first it has to have tangential velocity, right? The same thing happens in here. It has tangential velocity. So it has a change in velocity, of course, because at the very beginning it is at rest. Both of them are at rest. But first thing, after we release it, it has tangential velocity, but no any kind of centripetal acceleration. So there is no centripetal acceleration like this, or let me draw it some. Well, if the center is here, there is no any kind of centripetal acceleration. It's zero. The same thing happens in here. There is no centripetal acceleration here. It's 0 and 0 in both sides. This is 0. This is 0. At the very instant, they do not go circular at once. First, they have to have this change in velocity tangentially, okay? And then after it interacts with the wall and goes circular way, then the centripetal acceleration occurs. But at the very beginning of the process, immediately after we release it, it does not have any centripetal acceleration. It just has tangential velocity change, okay? Okay, so that's why we do know. Okay, let's write it. 4 equations. Let's say that this object is object 1, this object is object 2, and for object 1 we definitely know that there is no vertical motion because centripetal acceleration goes vertically, right? So it means that in y, in y direction, it goes like this. N minus mg because it opposes, and minus as well f, this is cosine alpha equals 0 because there is no motion. Basically, I can just move all of those things to the other side. It becomes just mg and plus f cosine alpha. F cosine alpha. Okay, good. This is equal. Okay. However, we have some change in velocity horizontally, and the only force which is acting on our ball horizontally, it is F sine alpha. There is no any other force opposing it. There is no friction. That's why it would be just x would be F sine alpha equals our ma. Okay, this would be our equation, both equations for our object 1. Let's write it y1 and x1. Let's write here y2. y2 and x2 for our second object. So y2 for this, the vertical forces acting on our second object. There would be motion in vertical direction because tangential speed is vertical. And that's why we know that this thing equals ma as well. So it must be what? F cosine alpha, no, mg. Mg is the direction of velocity, the change in velocity. So that's why it would be the main character. Mg minus opposes, the thing that opposes it, it would be F cosine alpha. F cosine alpha. F cosine alpha. And yeah, no friction, nothing else, just this. It would be equal to ma. Good. I believe that's it. For x direction, x2, let's write something like this. There is no motion horizontally, that's why it would be just n minus f sine alpha. N2, this is N2, this is N1, yeah, there are different normal forces, that's why we need to point them as N1 and N2. N2 minus f sine alpha, f sine alpha. It's the same f basically because it's the same rod, yeah, f sine alpha equals 0. That's how we know that N2 just equals f sine alpha itself. Okay, good, I like it. Now, what can we do with this information? Well, I believe these two accelerations, this acceleration and this acceleration, are the same, but in different directions. So the problem is just the direction, but it doesn't matter. The value is the same. So right now, the very important part is about this 45 degrees. It gives us some information. What information? We know that sine 45 degrees equals cosine 45 degrees, right? Because both of them are just square root 2 divided by 2. And that's how we can do this thing. I can take this thing, f sine alpha equals ma, just turn it into f cosine alpha equals ma. And I can take this thing, put it right here. So then you have what? If f cosine alpha equals ma, it means that mg minus ma equals ma. If I move this thing to that side, it's got to become mg equals 2ma, right? And we can just basically annihilate both of these m's, and a would be just g divided by 2. Okay, good. That is the value of a. Right now, what can we do? We can just take this thing. Basically we can find if, yeah, you can see this thing. I can again just take this thing and apply it here. So basically it's just this thing. N2 is obvious. N2 equals what? F sine alpha equals ma. It means that N2 equals ma. And we know that a is just g divided by 2, is just mg divided by 2, half of the mg. So this is the answer for N2. Yeah, it is solved. And if we just look at here, N1 is what? N1 equals mg plus f cosine alpha, and as you can see here, f cosine alpha equals ma, and that's how I can just do something like this, ma, right? And again, N1 equals mg plus, this is a is g divided by 2, that's why it becomes just like this. And if I give just 2 to mg, it will be something like 2mg plus mg divided by 2, it becomes just 3mg divided by 2. Okay, that's it. So that is the answer for N1. The only thing that we needed is just equalizing sine alpha to cosine alpha, and that's how our problem is solved very fast. Okay, thanks for your attention. If you have any problems, you can approach me privately, you can write me privately, and I believe that's the end of our video. Thanks for your attention. Goodbye.